The Leviathan and the Flaw. Imagine a machine designed to survive the crushing, pitch-black pressure of the deep ocean. A nuclear-powered Leviathan, forged from ultra-high-strength HY-80 steel, armed with Tomahawk cruise missiles, and capable of operating undetected anywhere on Earth for months at a time. This is the Los Angeles-class fast attack submarine, a 6,000-ton apex predator of the United States Navy. It cost the American taxpayers nearly $1 billion to build, engineer, and maintain. Every weld on its hull was inspected with X-rays. Every valve was tested to withstand ocean depths that would instantly flatten a conventional surface ship. It was engineered to survive enemy torpedoes, sub-zero Arctic ice fields, and the immense violent stress of modern underwater warfare. But on May 23, 2012, this multi-billion-dollar weapon of war wasn't destroyed by a foreign sea mine, a hostile missile, or a tactical error in battle. Instead, it was systematically executed by something so absurdly mundane, it sounds like bad fiction. A heavy-duty plastic vacuum cleaner, a pile of greasy cotton rags, and a single disgruntled civilian worker who just wanted his shift to end early. This is the technical and psychological autopsy of the USS Miami, SSN 755. It is a case study in how a closed, windowless cylinder of military-grade steel can turn a minor spark into an unstoppable thermal nightmare. It proves that the more complex and hardened a system is against external threats, the more vulnerable it becomes to a single catastrophic flaw from within. This story is not just about a fire. It is an investigation into the fragile intersection of advanced human engineering and unstable human psychology. To understand how a $500 million disaster could be triggered by a single lighter, one must first understand the state of the USS Miami in the spring of 2012. The submarine was resting inside Dry Dock Number 2 at the historic Portsmouth Naval Shipyard, located on an island in Kittery, Maine. It was undergoing a routine 20-month engineered overhaul, a massive, complex logistical operation where a nuclear submarine is stripped down, its sonar arrays upgraded, its internal piping replaced, and its tactical systems modernized to prepare it for another decade of silent service. When a submarine is in the open ocean, it is in its natural element. It is a living, breathing organism. Its nuclear reactor is constantly cooled by an unlimited supply of cold seawater, and its crew lives in a state of hypervigilance. On a submarine at sea, fire is the ultimate enemy, the absolute worst-case scenario. Because there is nowhere to run, every single sailor on board, from the cook to the commander, is a highly trained, certified firefighter. If a spark appears in a control panel at sea, it is suffocated with chemical extinguishers within 15 seconds. But inside a dry dock, a submarine is at its most vulnerable. It is a fish out of water, trapped in a metallic cradle, stripped of its natural defenses. The moment a submarine enters a dry dock, it ceases to be a pristine, sealed military vessel and becomes an industrial construction site. The ship is disconnected from the sea, meaning its natural cooling sources are gone. More importantly, its heavy internal safety hatches, which are designed to seal off compartments in the event of a hull breach, are permanently propped wide open. This is done to run miles of thick, temporary power cables, high-pressure breathing air lines, and temporary plastic ventilation ducts from the shipyard outside into the deepest parts of the vessel. Furthermore, the submarine's built-in automated halon firefighting systems are completely deactivated drained or isolated for maintenance. The crew is no longer in full control. Instead, the ship is handed over to hundreds of civilian contractors, shore-based technicians, painters, and sandblasters. During an overhaul, the interior of a submarine is a cramped, chaotic maze. The narrow, claustrophobic corridors, usually kept perfectly clean, are cluttered with industrial debris. Insulation material, flammable paint thinners, chemical cleaning solvents, plastic scaffolding, and heavy welding blankets are piled in the corners of the living quarters and equipment bays. It is a technological marvel packed tight with high-energy tinder, waiting for a spark. Among the hundreds of civilian contractors walking these cluttered corridors was Casey J. Fury. He was a 24-year-old local resident, hired as a sandblaster A, the Firestorm, inside the cylinder. At 5:41 p.m., Casey Fury's wish was granted. Smoke began to drift from the storage space, triggering the evacuation sirens. Workers dropped their tools and scrambled up the vertical ladders. At first, everyone assumed it was just a minor welding flare. They were catastrophically wrong. The alcohol-soaked rags inside the vacuum cleaner exploded into an intense chemical fire. The plastic housing melted instantly, feeding the flames. Within 5 minutes, the fire breached the locker and found the ultimate tinder: acoustic insulation blankets and wood-grained formica panels lining the crew's quarters. Here, the brilliant engineering of the nuclear submarine became its own enemy. A submarine is a steel cylinder built to keep things out, specifically ocean water. It has no windows or structural air vents. When a fire ignites inside, the steel hull acts like a massive cast-iron skillet, trapping and reflecting the thermal energy. The temperature inside the forward section skyrocketed to 1,400 degrees Fahrenheit, over 760 degrees Celsius. The internal bulkheads began to glow a terrifying cherry red. When firefighters descended into the vessel, they stepped into a blast furnace. Because the automated halon gas systems were deactivated for maintenance, they had to drag water hoses from the dock. The black, toxic smoke from burning plastics was so dense that tactical lights could not penetrate it. Firefighters were operating in absolute darkness, crawling over a hot steel, feeling their way through the maze purely by touch. Worse, the temporary plastic ventilation ducts installed for the workers acted like a giant mechanical lung. The shipyard's ventilation systems continued to pump air inside, creating a violent draft. Instead of clearing the smoke, this fresh oxygen fed the flames, creating a blowtorch effect that systematically melted the multi-million-dollar sonar arrays and navigation computers. As the night wore on, the crisis escalated into a potential nuclear emergency. The fire was moving aft toward the reactor compartment, which housed the submarine's S-6G nuclear reactor. Although the reactor was shut down, it still contained a highly radioactive fuel core. If the fire breached the heavy lead-shielded bulkheads, the intense heat could disrupt the temporary cooling pumps, risking a localized meltdown and a radiation release into a densely populated coastal region. Over 100 firefighters fought the blaze for 12 agonizing hours. The heat was so intense that water from the hoses instantly turned into scalding steam. They also faced a terrifying engineering paradox. Pouring too much water into the submarine would make it top-heavy, causing the 6,000-ton vessel to roll over inside the dry dock, crushing the active infrastructure below. It was a high-stakes game of physics played in the middle of an inferno. Finally, at 3:41 a.m., The fire was extinguished. The reactor compartment had been saved, but the forward half of the USS Miami was nothing but a charred, melted skeleton. The NCIS investigation was swift. Under polygraph testing, 24-year-old Casey Fury broke down and confessed. He admitted to lighting the rags with a cheap cigarette lighter, reiterating that he never intended to destroy the ship. He just wanted his anxiety to stop, and he wanted to go home early. In March 2013, Fury was sentenced to over 17 years in federal prison and ordered to pay a symbolic $400 million in restitution. The U.S. Navy initially wanted to repair the USS Miami, estimating the cost at $450 million. But as naval architects cut into the hull, they discovered a fatal truth. The intense 1,400-degree heat had altered the molecular integrity of the HY-80 steel. The hull had lost its elasticity. If the submarine submerged, the immense pressure of the ocean would cause the weakened steel to collapse like an aluminum soda can. Rebuilding the entire forward half pushed the estimate to over $700 million. In 2014, the Navy officially decided to scrap the ship. The destruction of the USS Miami remains one of the most expensive cases of industrial sabotage in military history. It stands as a chilling reminder. You can spend billions to build a weapon capable of surviving the pressures of the ocean and the armaments of an enemy. But in the end, its survival still depends on a pile of greasy rags, an industrial vacuum cleaner, and the unstable mind of a single human being. Every system has its breaking point. Sometimes the critical error isn't in the machine, it's in us.